On today's video, we're going to travel to the desert country of Mauritania, located in West Africa. I've been working on this video for over 5 years and it's finally complete. This video is a culmination of testing the local methods of gold mining and gold recovery versus more modern equipment such as shaker tables and smelting. The goal is to improve the local miners' ability to recover more gold without using mercury or cyanide with more modern equipment. I want to start this video with giving you a brief overview of the equipment we're going to be using, as well as introducing some of my partners, and then we're going to jump right in to processing and testing, and by the end of the video, we'll have a clear picture on which method recovered more gold. All right, we've just arrived at the yard. Here's our first look at the equipment. Here's a quick little overlook of the whole system. There's the jaw crusher. They put it in buckets, bring it up this staircase here to the hammer mill. The ore is fed down the hammer mill chute. They run it wet with water to keep the dust down. And then it comes down this chute into the wet pan mill or the cone mill, where it does finer grinding than the hammer mill can do. The object is to liberate more gold, and then down that outlet box, down the pipe, and onto the Mount Baker mining metal shaker table. The gold and the sulfides fall down into these grooves and work their way across the table, down into the number 1 and number 2 port right here where those buckets are. They go down under the shaker table, collect the high-grade concentrates. There's a middling section right here that captures some of the higher grade concentrates that you don't want to go down to your tails. These are mostly a mix of sulfides and quartz. And then the quartz tailings flow down into the number 4 section here. They both, number 3 and number 4, settle in these basins here, and then the water flows out this gray pipe down into these settling ponds to a pump right here that recirculates the water to the hammer mill, cone mill, and shaker table. A nice little system. This was a nice little system they set up with mostly Mount Baker Mining and Metals equipment, and it does a really, really good job. It's a really great system for test work. So I want to introduce one of the partners, kind of the reason I'm here. This is Daniel Stapper from PACT.
Thanks, Jason. Yeah, my name is Daniel. I'm Canadian, but I work with an NGO, a nonprofit called PACT Inc., based in the US. We do work all over the world, actually, in our mining group. It's called Mines to Market. There's actually millions of people in this small-scale mining sector around the world, not only in gold, which is my primary focus, but on a lot of other minerals.
Here in Mauritania, our project is called the Business Pilot for Responsible ASM Gold. And in this project, the funding comes from the European Partnership for Responsible Minerals, EPRM for short. There was a modern gold rush here starting around 2016, and this project is designed to support the government and the people here in Mauritania to get as much benefit as possible from the artisanal mining sector. In practice, this means support for safer mining and safer mineral processing without mercury. A key aspect of the project is support for private sector partnership, and in this case our local partner is a company called Magma. Magma is a successful geotechnical services company who provide services to the mining sector, and it's thanks to this innovative private sector partnership that the EPRM project has been able to set up this mineral processing facility in the city of Nouakchott, where solutions for the local artisanal mining sector can be tested and optimized.
Here's the ore we're going to be running for our samples. And this is characteristic of the ore they get from their hard rock mines. They mine quartz veins, narrow quartz veins, and the grade here could be running anywhere from 5 to 30 grams per ton. And we're going to try and split these bags up into maybe 6 or 8 different samples and run different samples. I'll explain our methods here in a little minute, but figure out how to recover the most gold from these ore samples without using mercury chemicals, and then we're going to test as a control. Hopefully we can get some of this ore up to the local miners and have them test with their local methods to see which recovery is better. Here's the 6x10 jaw crusher. Got it up on some concrete blocks. Works well. We got our dust masks on. We're crushing dry into these sacks so we can mix it and get a representative sample for our head ore, and then we'll split it into different samples to run and test. We got our first bag there crushed. Jaw crusher's running. We're in production now. Well, this is a test pan from the first 3 bags, and they have that large screen in there, so it's fairly coarse. But I'm going to do a test pan to see if we have any color in this at all, and that'll hopefully tell us if we have some gold to recover here. It's quite fine, that one larger piece on the left there, but it's, judging by this test pan, it's fairly low grade. We've got all the ore crushed through the jaw crusher. We're working on getting it crushed through the hammer mill. So we're making progress. Here's our wet pan mill, cone mill. Call them cone mills here. These big, huge wheels go around and crush the ore. And when it's crushed, they open up this door and it goes out. We're going to run it as a batch system. And so we're going to load the ore in here and let it circulate for half an hour to an hour. And then we'll open the door and it'll flow down onto the shaker table. So we have some water going into the wet pan mill or cone mill. So we'll get the ore spread out as best we can and get the wheels turning.
Yeah, well, the idea being, this, once mixed up, this is going to be our mixing it around and then getting our 30-minute sample. Yeah. Some of it is slightly finer, some of it is coarser.
We've run our 45 minutes. Now we've opened the gate a little bit. Starting to let the fine material that's suspended in the water run down onto the shaker table. It's quite fine. See how much gold is in this material. Our test pan didn't show very much. And it's working very, very nicely. All the fine quartz is working up to the ramp and then down into the tailings. We have the splitter set almost all the way. So all the quartz is running this way. There's a nice little band of sulfides here. It comes down a little bit going into the number 3. Most of it's coming across into the number 2 concentrates. Very nice and clean. From the last groove here, there's a sweeping band of sulfides that just are grabbed by the number 1. And there's a little line of what might be very fine gold up here under the water bar. We've got the water mostly drained out of the cone mill. This is the best material. The gold will mostly be down here. And we're gonna work on getting it scooped up and cleaned out. And then I'm gonna manually feed it down here onto the shaker table. We're finishing the run now. We've pretty much got the wet pan mill cleaned out. There's a lot of steel on the table, you can see here. Kinda. Hopefully there's some gold mixed in with that. I don't see a lot. I think we're concerned we may have some low-grade material here.
These are the samples from the port 4 and port 3, the tails and the middlings.
Okay.
That we'll do grain size on and check for gold.
Get assayed.
Yeah.
And that'll tell us how much we lost. We've done our absolute best to get this as clean as possible. Daniel, are you happy?
Yeah, well,
It is what it is?
it is what it is. Yeah, just making sure that the sand that's caked in here is not our material. Maybe some of it is.
Yeah.
Sort of an imperfect situation where we're trying to get it as clean as possible to make sure we're getting the gold values from this test onto the table.
Now I'm going to brush down the table here and move all the concentrates across. This is the number 1 concentrates. Very little in there, which is about how it looks when I run it back home. And the number 2 has a significant amount of sulfides in it. Black sand, steel bits on top. So we will combine both of these into one gold pan, and I'm going to pan them down to get a visual check. And we're going to keep out 200 grams? 200 grams, and we'll smelt the panning concentrates and see how much gold we have. I've panned it down. There's probably 50 grams, 100 grams here, something like that. A significant amount of steel. All that shiny whitish stuff is steel. So we're going to use a magnet here and pull out what we can. Yeah, go ahead, Daniel, see what you can get out of there. Here's our gold from our first test. This is through the wet pan mill onto the shaker table and panning down the concentrates. And there is not much gold there. This is from 150 kilograms, and we estimate that's 0.1 grams, maybe less.
Just because it's so fine. The color looks nice on the video, but it's so small.
It's very fine gold. Oh, and there it goes floating away. So we have some head samples off for assay. We'll know more in a day or two about how much the head grade is, but we were hoping for more. We were hoping for what, a couple grams?
We were hoping for 10 or 15 grams per ton.
Right, but a couple grams in the pan is what we were hoping for, right?
Well, yeah, the miners like to say that it averages a gram per sack, and so this is equivalent to 2 good-sized sacks that was processed. So 2 grams. 2 grams would have been wow, but this is way less than 1 gram.
When we arrived in Chami, we saw hundreds of these Chilean or cone mills, as you can see here. And the miners would hand crush the rock down to about 2-inch minus and dump 10 sacks of ore into the bottom of these Chilean mills and add a huge amount of mercury, a couple kilograms of mercury, to the bottom of the trough. And these big wheels go around, and it's called whole ore amalgamation when they use mercury with the raw ore. And they just crush it all together and squish the mercury and ore together, and as the gold is liberated, the mercury amalgamates with the gold. And here you can see some of the sacks they use and the size of the rock they feed into these mills. And here's a tub of the concentrates we're going to take over, and he's going to show us how he squeezes the mercury out and gets his gold out of the concentrates from the cone mills. These cone mills hold about 10 sacks of ore, and depending on the hardness, they can run the cone mills for anywhere between 8 and 24 hours for 10 sacks, and each sack weighs 50 kilograms, so they can only process about half to 1 ton per day.
But it's coming from the drum, yeah? The mercury is inside.
Daniel, you want to give us a 10-second description of what we're looking at here?
Sure. Yeah, these cone mills are processing the rock, which they're adding mercury directly to, and that mercury, this is the material coming out of the cone mills after 8 or 24-hour process. So you can see the mercury in it if you look closely. You can see the silver balls of mercury. That's got gold in it. All of the mercury you can see has got gold in it. And so then they'll wash it and they'll get the mercury, and then they'll press the mercury through. They'll filter it in order to recover the gold.
With pezzo di mercurio e pieno di oro. Bruceranno.
And they burned it. They burned this off in the little charcoal burner. And then here's their gold sponge. So now he's taking the gold sponge, and he's going to melt it down into a little gold button. There it is.
Take a picture.
Yeah, boom.
Oh, and here comes another
batch.
There's another sponge, and he's going to do this process again.
One bag. This is one bag.
No.
So after seeing how the Chilean mills were working, I wanted to test the tailings that were coming out of the Chilean mills. So I went over and I tried to convince this guy to give me a shovel full of tailings out of the tailings trough. And I'm going to pan it down and see if we can recover any gold or mercury that was lost by the mills.
He asked you if you want a job with him.
A job?
he finds that you pan very well.
I pan well?
Yes.
What we're doing here is we've taken some tailings from the cone mills, or the Chilean mills, and I'm testing to see if there's any gold or mercury left over. Let's give this a swirl here. I've panned down just one pan of tailings.
Okay.
So see, this is all mercury that escaped from the mill, and this was just one pan of tailings. So in one pan of tailings, there's a significant amount of mercury left in the system, even after they're done with it. And some of this mercury may have gold amalgamated with it. So if they're losing mercury, they're surely losing gold as well. By taking the waste from the current mining, you can actually clean it up and recover a lot more value, as shown here by burning off the mercury that you saw in the pan. This is the amount of gold they lost from one pan of tailing. This is going to be our duplicate from the run we did yesterday. The guys are finishing up crushing the rest of the stuff through the hammer mill. And we'll have 2 runs on the shaker table with cons for direct smelting, and we have 2 bags over here, 2 samples, 1 and 2 for whole ore amalgamation back at Chami, to test the recovery of the way the miners do it now versus the new system with direct smelting. So here's the results from our second test through the cone mill onto the shaker table. A significant amount more gold than what we had yesterday, which is good. And we're going to save this out for direct smelting, our second direct smelting test. This is going to be our first real smelting test of our concentrates. This is what we did the first sample, the first day, through the cone mill onto the shaker table. We're going to direct smelt the concentrates. We've panned the concentrates down to 100 grams, and we've added 300 grams of a flux recipe that Daniel likes, which is 1 part silica, 1 part soda, and 2 parts borax. So we'll get that in the furnace and we'll give it a shot. How much lead are we going to add?
I like 4 grams.
4 grams, okay.
Yeah, then you end up with a prill that's right around 4 grams. Hopefully it's now got gold in it. That's the idea.
Yeah, and it's easier to cupel that way.
Yeah, and
There's our little pucks.
Lead pucks that come from the metallurgist experts in Spain.
Awesome.
So,
all right,
it's pure lead.
We'll get it mixed up and put it in the furnace.
I already oiled that.
Okay. And this is our first smelt from the first day. Shaker tables, cons, direct smelting test. This is our moment of truth.
Not bad.
What is this? 0.78 grams.
Yeah.
From 108 kilograms. That's pretty good. That's 7.5 grams per ton. I mean, roughly, with my quick math. This is our bismuth collector metal that I poured into the water and increased surface area. And one thing I forgot to say earlier is we've added 1 gram of silver to this, 1.06 grams of silver to this, to try and help collect the gold. And so when we get our bead at the end, we're gonna have to subtract that 1.6 grams of silver out of our bead. But our hope is, we talked to somebody today that said putting silver, a little bit of silver in there will help collect that gold better. So we're gonna try it. Here's our prill all cleaned up, and surprisingly it's quite soft, it's quite malleable, and my experience has been that the bismuth is quite brittle if it's mostly pure bismuth. But I'm thinking maybe that little addition of silver and any other precious metals we collected in here has made it not brittle, which is really, really nice. We don't have a real nice smooth top, it's kind of gnarly on top, but hopefully we got some good recovery here. And we'll see what happens after we cupel it. Wow. We added 32 grams and we ended up with 34.75 grams of metal.
Should we lift it out then?
Yeah, here's our button. We're done cupelling. It's a pretty good size button. We got to take out our 1.06 grams of silver, I think is what it was. But there's an appreciable amount of gold there. All right, here's the moment of truth. 2.5.
Wow. That means we got 1.5 grams of gold on this one.
Yeah, yeah.
That's an incredible result. It actually aligns quite well with the good pour you did on sample 2.
It does.
Yeah.
Because we did twice as much. And
yeah.
We got 0.78 grams, I think. Awesome.
Good result.
Yeah, we'll do some math here, figure out our recovery.
Well, hello guys, this is Levin. So now we are processing one of the samples. So the protocol is just to process one sample at a time separately. One sample is around 100 kg. It's not the same as they do here. They work per batch, and it's around 350 kgs per batch for them. But now, the case of our testing, we're just processing 100 kg at a time. For mercury quantity that they add, so for each sample, so for each 100 kg, they add inside the wet pan mill 300 grams of mercury, and then when they got also the concentrate that they pan, they add another 300 grams. So in total for each sample, it's
100 grams. So this is the first sample that we grinded almost for 5 hours in the cone mill, and that's the grain size for him. That's actually fine enough. So this is the concentrate of the shaker table. You add some mercury in it, and you just pan it for a few, say, a minute and a half. Let's see. So now, this is the first one from the head sample 1, and this is from the head sample 2.
And here are the results for our test, and you can find the full report in the description below. I have a link to it down there. But I was really happy with the results. The gray-brown bar at the bottom shows that the gold recovery using just the shaker table and direct smelting was about 74%, versus the gold recovery using mercury was about 58%. And we recovered about 15% more gold using just gravity and smelting versus the local mercury methods. So we're going to do a little maintenance training on the hammer mill and the jaw crusher. I've been explaining to the guys that there's 4 main things: hammers, the screen, the armor, and the belts and motor. And then the bearings are a little bit separate because we can grease those every day. But as far as maintenance is concerned, we're going to start with those. And these guys are working on taking the lid off right now. So we have the lid off. Here's the hammers. I'm going to show them how to change the hammers. We take off one of the side plates here, and then we can just slide the pin out, and they can take the hammers off. But this is run maybe 2, 3, 4 tons, and they've just barely worn the corner edge off the hammer. So there's lots and lots of life left on the hammers. And then the hammers can be rotated around this way, and then you can start wearing on this edge. So there's many tons left in the hammers. They're going to work on this, on taking these side plates off now. I think I missed it on video, but it was pretty exciting there. But we got the one pin out and back in, so they know how to change the hammers. Next, we'll do the armor. So we'll take off the bolts that hold on the armor on the inside, both sides, and then I'll show them how to roll the screen out, and then we can roll it back in so they know how to change the screen. All right, we have the screen out. This is very good. Yeah, you wash. Yeah, wash. It's okay. Water. Yeah. Out. So you can wash it all out. That'll make it easier to get back in. Let me no grease. No grease. These guys are experts now. They've changed the screen. They've changed some hammers. They know the machine inside and out. All right, well, they have successfully changed the hammers, taken out the armor. They've pulled the screen out and put it back in all by themselves. We've talked all about this armor. We've talked about changing the bearings and what we call our flingers, where the water comes in and it sprays water around to get everything wet. So they're doing a great job. They're doing a great job. We're going to take lunch. We'll check the belts and talk about how to tighten the belts with the jacking screws, and they'll be all set. We're working on the jaw crusher this morning. So we're going to first start with changing, or not changing, but taking out and replacing the jaw plates so they can see that. See that process? The jaw dies and the cheek plates here on the side. So we'll take out the swing jaw, the stationary, and the 2 cheek plates. And then we'll put them back in so they know that process. All right, they got the stationary jaw die out. Yep. There's the first one. Now we'll get the swing jaw die out. All right, we've hit a little bit of a snag here with these 2 bolts that hold in the swing jaw die. They don't have a socket and ratchet. All they have is end wrenches. And it's quite interesting trying to translate from English to French to Arabic what tools they need. I'm trying to tell them a deep well socket with a small extension and a ratchet is all they need. But I think it's either being lost in translation or they don't have one. But this is our holdup right now. But everything else I think we can do. We took all this apart when I first got here and showed them. I'll have them do that again today. But it's those 2 big bolts and nuts on the back here that are giving us problems right now. But as soon as we get those 2 out, then we're home free. We can take it all apart and put it back together, and they'll be experts on the jaw crusher as well. All right, ingenuity here. We got a tire iron with a little extension and a deep well socket. We'll get a bar for them, but I think we're set now. All right, we got it. They made a tool. They welded up what they needed to get the socket there. Still hot, I think. We're getting it now. All right, they're just getting the jaw crusher back together. They're doing a pretty good job. I'm actually pretty impressed with their ingenuity, and they're quite mechanically inclined. They understand the machine, and so I don't think they'll have any issue working on the hammer mill or the jaw crusher. They're simple machines. They got the jaw crusher all back together. Just runs really nice. We actually did a little test run down here. You can see it turned out real nice. So they did well. We got the jaw crusher and the hammer mill. Got them all trained up on that. So they're pretty much experts now. They can take it apart, put it back together, do any adjustments they need. So good work, guys. All right, guys, well, this has been an awesome trip. I really appreciate you coming along with me. If you want to see more stuff like this, be sure to subscribe. I think we're going to have some awesome results when that paper comes out and we have all of our data. I'm going to put a link to it down in the description so you can check out the full results of our week here in Nouakchott, Mauritania. And I wanted to mention a huge thank you to Magma, our partner here in country, and Pact, who invited me here and has really been instrumental in getting all this going. And they do a lot of good work all over the world doing stuff like this. And so check out their websites. I'll put a link to their websites in the description below as well. So check them out. So thanks for watching, and we'll see you on the next video.